Hello! Okay, so we started 4.4, and what I wanted to do with the videos today is do one question talking about the equation of kind of something more abstract, and then question 2, example number 2, is going to be something a little bit more practical. I say practical a little bit loosely because oftentimes when we use mathematics to model real-life situations, we're assuming that the situations are perfect. That there are no imperfections in the building materials, that sort of thing. We'll talk more about that when the time comes, but for now, let's focus on this first question. So, a quadratic function passes through 2 points. Point C at the coordinates -1, -6, and D, 5, 0. The axis of symmetry is 3, or x equals 3. What is the equation? First things first, we got to start off with the vertex form of the quadratic. So let's just talk about it in general. So y equals a x minus p squared plus q. Remember, q is how many points it moves up or down. P is the number of points or units that moves left or right. A is that vertical stretch or compression factor. And that's about it. So what we first want to do is we want to use the information that we have right here, x equals 3. So since x equals 3, it means that that horizontal axis, that vertical axis of symmetry is no longer at 0, which is the mother function, but it is now at 3. Okay, so that means that p is 3. That means that when we substitute it into here, it's going to become y equals a x minus 3 squared plus q. Great. So we have one less letter to deal with. That is fabulous. What we want to do in this question here is we want to substitute. We want to use both c and d. So if I were to substitute for point C, which is -1, -6, my x is going to be -1, and my -6 is going to be my y. So instead of y, I'm going to put -6. We still don't know a. X minus 3 squared. I made a mistake here. I shouldn't put x, right? Because we know that our x is actually -1. So -1 minus -3 plus q. We still have 2 unknowns, but we're going to develop 2 equations. We have 1 point, and we have another point. We have d. So what we can do is we're going to get this in terms of q. That's the easiest way to do this. So when I do this, -6 equals -1 minus 3 is 4. Squared is 16. So 16a plus q. I could isolate the a, but guess what, guys? Isolating the q is way easier. Why? We don't have to divide by 16. So 16a, right? We could solve for 16a, and then we have to divide by 16. To isolate that a. That's not very nice. We don't like fractions all that much. So what I want to do is I want to isolate that q. So what we need to do is subtract 16a from both sides. So we get -16a minus 6 equals q. I'm going to put a box around this, and I'm going to call this equation 1. You'll see why in a bit. What happens with equation, or with point D? We have it being 5, 0. What I want to do is I want to take the same approach. I want to substitute this into this equation. Not this equation, because we already know what p is, okay? But this equation here, because we have 2 unknowns, because we're going to solve for x, or we're going to substitute in for x and in y. So then I would say 0 instead of my, so this is my y, this is my x. So 0 equals a x, but x is 5. 5 minus 3 squared plus q. So you say 0 equals 5 minus 3 is 2, squared is 4, 4a plus q. Now again, what I can do is I can solve for the a, but we're going to have to divide both sides by 4. We're going to end up with a fraction. Oh. So let's subtract 4a from both sides. Negative 4a equals q. I'm going to put a box around this and call this equation 2. Look, this is a gift from the mathematical gods. Look, q equals this. Guess what? Q also equals this. Okay? So if q equals negative 16a plus 6 and q also equals negative 4a, it means that negative 16a minus 6 equals 4a because they both equal q. So what I'm going to do is I'm going to set this section, these two sections of the two equations together because they both equal the same thing. So I'm going to say negative 16a minus 6 equals negative 4a. Guess what? One equation, one unknown, we can do it! So I'm going to add 16 to both sides. So we have negative 6 equals 12a. I'm going to divide both sides by 12. So we're going to have something like a equals negative 0.5. This is something important. Guess what? We can substitute that in for here when the time comes. Now the next thing that I want to do is, so we have our a. The next thing that we need to solve for is that q. But look, negative 4a equals q. No problem. So if q equals negative 4, and if a equals 0.5, I can just substitute that into here, 0.5, negative 0.5, sorry. Then q equals 2. So now I know what my a is, and I know what my q is. So what I'm going to do is I'm just going to write that equation so we know everything. At the end of the day, you should only, if it's asking for the equation, you should only have the x and y variables that are unknown. Because that's how we graph things. We need to have both x and y. So the final answer is going to be y equals, I know a equals negative 0.5 times x minus 3 squared plus 2, because q equals 2. This is my final answer. Put a box around it. Make your teacher happy.